Hi everybody, here is an answer key for the Lesson 7 homework, Trig Lesson 7 homework on the sine law. And remember, the sine law is used when we don't have a 90-degree triangle. So if you have sort of just a general triangle like this with no 90-degree box, A, B, C, and remember, across from the capital letter angles, we put little letter A here for this side, little letter B here, and across from the capital C is little c like that. And sine of angle A divided by its opposite side equals sine of angle B divided by its opposite side. And those two are also equal to sine C over C, and that was the sine law. Okay. So let's do number 1 here. Solve for the indicated side. Write out the ratio and show all steps. It wants us to find from A to B. Okay, so it wants us to find this side here, which is across from the C. So it wants us to find little c. And we need to have what's called an angle-side relationship, an angle and its opposite side, to be able to use the sine law. And fortunately, we we do. So if this is capital A here, then this will be little a, and we can go sine A divided by A, little a, is equal to sine C divided by little c. So I would say that sine of 35 degrees divided by its opposite side 4 is equal to sine of 65 degrees, which is angle C, divided by its opposite side, little c, and we just have to solve this equation for c. Okay, excuse me. When we have two fractions that are equal to each other, we can do that cross-multiplying trick, and we would get c times sine 35 is equal to 4 times sine 65. And then to get c by itself, it's being multiplied by sine 35, so I would simply divide both sides by sine 35 and say that c is equal to, let's get out the calculator. Notice that my angles are in degrees, so I'm going to quickly go mode. Oh, I'm in radians, so let's change that to degrees. See how degree is highlighted. And I'm going to go 4 sine 65 divided by sine 35 and go like that. 6.3 is the length of C, which is the AB side. And that is going to be in centimeters because the 4 is in centimeters. Okay, and you'll notice that that is correct with the answer key. Okay, let's do letter B here. Find XZ. XZ is this length right here, which is across from the angle Y, so we could call it little y. And we've got this angle, capital Z, across from that will be little z. So we have an angle-side relationship. So I'm going to go sine Z over Z equals sine capital Y over little y, because we want to figure out what little y is here. Okay, so I would say sine of 93.4 degrees divided by its opposite side, 33.1 millimeters, is equal to sine of y, which is 67.2 degrees, divided by its opposite side, little y. Cross multiply. Okay, and notice that y is being multiplied by sine 93.4 degrees. So I'm going to divide both sides by sine 93.4 degrees. Okay, so y is equal to 33.1 sine 67.2 divided by, make sure that looks good, sine 93.4. Bang. Okay, 30.567 and all that. Okay, so if we wanted to round to one decimal place, I would look to the number to the right. The 6 is 5 or above, so that would get rounded to 30.6. And that is going to be millimeters. All right, in letter C here, they want us to find PQ, which is this side here. Okay, it's across from angle R, which we don't know at the moment, just little r. We do have an angle side relationship. So we are going to use capital Q and little q. So I'm going to go sine Q divided by little q is equal to, we want to figure out little r here. So we're going to have to use its opposite angle, capital R. Okay. And you might look at this and go, hey, the problem is we don't know angle R, but we can figure out angle R because we know two other angles. Angle R is going to equal 180 degrees minus 106 degrees minus 47 degrees. Okay, because the angles in a triangle have to add to 180. Okay, so if you have two of the angles, you can go 180 minus both of those to get angle R. So 180 minus 47 minus 106, and we get 27 degrees for angle R, and now we are in business. Okay, so now I can go sine of 47 degrees divided by its opposite side, 28, is equal to sine of capital R, which is 27 degrees, divided by little r, which is what we are looking for right here. Okay, which matches up with this PQ that they're wanting us to find, that length. Okay, so now we do our little cross-multiply trick. So we are going to get R sine 47 degrees equals 28 times sine 27 degrees. And then divide both sides by sine 47. And so R is equal to 28 sine 27 divided by sine 47, and we get 17.4. And that is going to be meters. Okay, and you'll see that that is consistent with the answer key as well. And 30.6 is good too. Okay, number 2, solve for the indicated angle. So this time we're going to solve for an angle. Be sure to write the ratio and show all steps. Okay, and again, if you look at these triangles, there is no 90-degree box showing. And if you have an angle and its opposite side, and we have like another side and we're looking for an angle, then we can use the sine law. Okay, so to find angle B, we want to find this angle here. Do we have its opposite side? Yes. Okay. So this is little a, this will be little b, and we can say sine A divided by little a is equal to sine B divided by b. So sine of 45 degrees divided by 9 is equal to sine B divided by 5. Okay, and so we could do the cross multiply thing here. We ultimately want to get angle B by itself. So if we start off with cross multiplying, you would have 5 sine 45 degrees equals 9 sine B, and then I'd have to divide by 9 again anyway. So notice that the 9 is just going to end up on the other side down below again. So it's just kind of like the 5 just goes and multiplies up top there, is really what's happening. So we will end up with sine B is equal to 5 sine 45 divided by 9, which is that, 0.392 and a bunch of stuff. I don't want to lose those decimal places because I want this to be as accurate as possible. So now to get angle B, remember to get an angle, you have to go shift sign, second function sine of this ratio. Okay, so if I'm going to go second function sine, I want to put that whole answer in there. So notice the word answer is underneath the minus sign, or the negative sign, the bottom of the calculator. So I go second function, that negative sign right beside the word enter, and it puts in answer. And when I do that, I get 23 degrees. Okay, 23 degrees. I'm noticing in the answer key that they're doing the angles to the nearest degree, so that looks good. Okay, how about in B here? Find angle K. So they want us to find angle K. We do have its opposite side, little k. We have an angle side relationship here, J and little j. So I would go sine J divided by little j is equal to sine K divided by little k. So sine of 74.1 degrees divided by its opposite side, 58.1, is equal to sine of angle K, which we want to find, divided by 41.9. Okay, and so we can do this a slightly different way if you don't want to do cross multiplying, because let's just multiply both sides by 41.9. Maybe I'll show it as a times sign instead of that dot. Times 41.9, so see how it cancels on that side, and you're left with sine K equaling all of this, right? So sine K is equal to 41.9 sine 74.1, bang, divided by 58.1, 0.693, and then to get K by itself, we have to do sine inverse of this. So we go shift sign, and I have to go second function negative key there at the bottom beside that enter key to get the answer in there, and that is going to be 44 degrees. Alright, letter C, find angle N. So they want us to figure out this angle. Okay. But we don't have its opposite side either. Okay, so here's what we're going to have to do, guys. We do have an angle side relationship. And then we have this side, which using the sine law would enable us to get that angle. So what we're going to have to do is we're going to have to get angle P first. And then once we have the 40 degrees and angle P, we can use angle sum of triangle to get angle N. Okay, so this is kind of a two-step question. So I'm going to have to go sine of capital M divided by little m. So this would be little m equals that. That's going to equal sine of angle P divided by little p, which will be over here. So we're going to figure out angle P first. So I'm going to go sine of 40 degrees, that's angle M, divided by little m is 30, equals sine P divided by little p is 21. And to get sine P by itself, it's being divided by 21, so you have to multiply both sides by 21 first. And so sine P is equal to 21 times sine 40 divided by 30, bang, 0.4499 and a bunch of stuff. So then P is equal to sine inverse of that. Shift sine of that, which is about 27 degrees. Okay, so this angle is 27 degrees, and then we can say, therefore, they want us to find angle N. All three angles in a triangle add to 180, so if I go 180, take away 40 degrees, take away 27 degrees, 180, take away 40, take away 27, and we get 113 degrees for angle N. Okay, and you'll see that in the answer key. All right, number 3. A roof has a span of 12 meters. The angles of the roof are 35 degrees and 20 degrees with the horizontal. Determine the length of both slants of the roof to the nearest tenth of a meter. Okay. So they want us to find little c here, and they want us to find little a. Okay, and you'll notice as of right now we do not yet have an angle-side relationship. Okay, we don't know an angle and its opposite side. Okay, but we can get that pretty easily because we know these two angles, so I can get angle B pretty easily using angle sum of triangle. 180 take away 20 take away 35 is 125 degrees. So this is 125 degrees, and now we have our angle side relationship, and we can use the sine law. Okay, so this will be little b. So sine b divided by b is equal to sine a divided by a, and we can figure out a first of all, and then we can do the sine law again to get c. So I would have sine of angle b is 125 degrees divided by little b is 12 meters. Sine a is 20 degrees, and we're looking for little a. Awesome, let's solve this for a. So we would get a sine 125 degrees equals 12 sine 20 degrees. Divide both sides by sine 125. Sine 20 divided by sine 125, and we get A is 5.0 meters to 1 decimal place. Okay, and now to get C, we can go sine B divided by B equals sine C divided by C. B, remember, is 125 degrees. Little b is 12. Sine of capital C, 35 degrees, divided by little c. And now let's cross multiply. Okay, and so now to get c by itself, it's being multiplied by sine 125, so we're going to divide both sides by sine 125, and so c is equal to 12 sine 35 divided by sine of 125. Boom, 8.4. And that's going to be meters as well. Okay, answer key says 5.0 meters and 8.4 meters, so we're good. Alright, number 4. A radar station is tracking a cruise ship and a freighter. The angle between the lines of sight to the two vessels from the radar station is 100 degrees. The cruise ship is 4.5 kilometers from the radar station and 6.3 kilometers from the freighter. What is the angle to the nearest degree between the lines of sight from the freighter to the cruise ship and the radar station? Okay, so they're asking us to find this angle right here. And notice we have an angle-side relationship. So we could call this A and little a. And we want to figure out angle B, and we have little b. Wonderful. Sine A divided by A is equal to sine B divided by B. Sine of 100 degrees divided by 6.3 kilometers is equal to sine B divided by 4.5. And we want to get b by itself, capital B. The sine function is acting on it, and then we're dividing by 4.5, so I have to go times 4.5. Okay, and when you have like just a regular number multiplied onto a fraction, it multiplies onto the top, because there's a 1 sitting underneath the 4.5, so it ultimately just multiplies onto the top like that. Okay, so sine B is equal to 4.5 sine 100. Divide that by 6.3, 0.703. All those decimal places, so angle B is sine inverse of that answer. So I'm going to go second function sine to get sine inverse, and I want to put in that last answer. And if you look at the bottom of the calculator, beside the enter button, is like that negative sign, and you can see in yellow it says ANS, answer. So I go second function, negative sign, and then press enter. 45 degrees to the nearest degree. Alright, number 5. A yacht race follows a triangular course. The yachts cover 5.4 kilometers in the first leg before turning at an angle of 75 degrees. For the second leg, after the second leg, they make an 85-degree turn and head back to the start line to finish the race. What is the total distance of the race to the nearest tenth of a kilometer? So the total distance. Okay. So if we call this capital A and little a, and let's say this is B and little b, and then this could be angle C, and this is little c. Basically what we have to do here, guys, is we have to find B and we have to find C, and then we have to add B and C to A to get the total distance of the race. Okay. So let's first of all get angle C, because we know these two angles here. So I can get angle C by going 180 minus 85 minus 75. Okay, so 20 degrees in here. And we do have an angle side relationship. So I'm going to start with sine A over A. And then let's figure out little b first. Go sine B over B. And notice what we have here. Sine of 85 degrees divided by 5.4 is equal to sine of capital B, 75 degrees divided by little b. Okay, and we're trying to find little b. Okay, so we could cross multiply it first and go b sine 85 degrees is equal to 5.4 sine 75 degrees, and then divide both sides by sine 85. And so b is equal to 5.4 sine 75 divided by sine 85. Boom. 5.2 kilometers. Okay, and they want us to go to the nearest tenth of a kilometer. Okay, so we found B. We now need to figure out C. So let's do sine A divided by A again, because those numbers were given to us. Those are nice exact figures. Our little b that we found, we had to round. And we're going to go sine C over C to figure out little c here. Okay, so sine 85 divided by 5.4 is equal to sine capital C is 20 divided by little c. Okay, so I cross-multiplied, and I want to get c by itself, so I'm going to divide both sides by sine 85 degrees. And c is equal to 5.4 sine 20 divided by sine 85. Bang, 1.9, let's say. And then we can say, therefore, the total distance What is the total distance of the race? The total distance is A plus B plus C. And A is 5.4, written right up here, plus we found B as being 5.2, and plus C, which is 1.9 kilometers. 5.4 plus 5.2 plus 1.9, and we get to the nearest tenth, 12.5 kilometers for the total distance of the race. Okay, number 6. Joe and Bob are standing facing each other 630 meters apart when they see a plane flying overhead. Using clinometers, they estimate the angles of elevation of the plane to be 52 degrees and 68 degrees respectively. Angles of elevation like that. Which of the men are closer to the plane and by how many meters? Answer in the numerical response box provided. Okay, so if we call this angle A and this angle B, what they want us to find is what is little a and what is little b, and who's closer to the plane and by how many meters. Okay. So we're going to have to get this little c involved along with its angle, which we don't seem to know at the moment, but angles in a triangle add to 180. So you go 180 minus 52 minus 68, and we get 60 degrees for this. So I can go sine c divided by little c is equal to sine a divided by little a. So I can go sine of 60 degrees divided by 630 is equal to sine of angle A, which is 52 degrees divided by little a. And I can use that to solve for A. So cross multiply, and you get A sine 60 is equal to 630 sine 52. And then divide both sides by sine 60 degrees. And we are going to get A is equal to 630 sine 52 divided by sine 60. 573.2. Okay, that was little a, so Joe is 573.2 meters away from the plane. And now let's get little b. So I'm going to start with sine c over c equals sine b over b. Sine c is sine of 60 degrees, little c is 630. And we will have sine angle b is 68 degrees. And we are looking for little b, which is the distance that Bob is away from the plane. Let's cross multiply. And then divide both sides by sine 60. So you go 630 times sine 68, divide that by sine 60, and we get 674.5 meters. And so notice, guys, that A is Joe's distance to the plane, so this is Joe, and B is Bob's distance to the plane. Which of the men are closer to the plane and by how many meters? Okay, so Joe is closer. Joe is closer by 674.5 meters minus 573.2 meters. .5 minus 573.2, 101.3 meters. Okay, and if you want to, we can write it in here. This is where the decimal point is, and you go 101.3. It's positive, so we could even do that. We could go 101.3. Okay. There used to be a provincial exam that had you record answers like this. And so this was just a type of practice question for that. Alright, we are finally on to number 7, and it says find all the missing pieces of the triangle shown. Okay, so we are missing this angle right here. We are missing this side, which is across from angle A, so that's little a, and we are missing little b. We've got capital C, and this is little c. Okay, so first of all, angle A is easy to find, because angles in a triangle add to 180, so you go 180 minus 82 minus 57. And we get 41 degrees. Okay, so we found angle A is 41 degrees. Now let's figure out A and B. We've got the information for capital C and little c, so why don't we start with sine C divided by little c is equal to sine A over little a. We'll get A first and then we'll figure out B. So sine of 82 degrees divided by its opposite side is equal to sine of capital A, which is 41 degrees, divided by little a. And now let's solve this for A. Cross multiplied on both sides. A is being multiplied by sine 82, so I'm going to divide both sides by sine 82. And A is equal to 10 sine 41. Divide that by sine 82, and we get 6.6. And that's going to be in meters because the 10 is in meters. Okay, and in the answer key, they call that side BC. We just figured out A, which goes from B to C, so that makes sense. All right, now let's figure out little b. So again, I would go sine C over C is equal to sine B over B. So sine of 82 degrees divided by 10 is equal to sine capital B is 57 degrees divided by little b. And cross multiply and we get b sine 82 degrees is equal to 10 sine 57. And I put an extra equal sign in here for some reason. That's just going to be b sine 82. And then divide both sides by sine 82. .5 meters. Okay, and that is side B, which goes from A to C. Okay, so we can call this AC, and that's what they do in the answer key. Okay, so 41 degrees, 8.5 for AC, and 6.6 for BC. Okay. Alright, so there you go, everybody. Answers for Trig Lesson 7 on the sine law. And I will send you Trig Lesson 8 on Monday. It's on the cosine law. And then I think there's just one lesson after that, which puts everything together for trigonometry. And we'll do that the week after, and then we can do the trig test, open book, to help you improve your marks for the final report card. All right, everybody, I hope you're staying safe, and I will talk to you soon.